One places the origin of the universe in a great explosion, which would have occurred 13.7 billion years ago. Science is in a way traveling in the direction of past time. This time is imaginary, for the past no longer exists. Who allows us to make this illusory journey is cosmic radiation, as it has a fixed speed and limited to 300,000 kilometers per second. When it comes to astronomical distances to travel, light takes too long. It looks like a turbocharged slug. Nothing is known about the path this radiation from the Big Bang might have traveled in space before reaching us on Earth. As the time that would separate us from the hypothetical singularity would result from an indirect assessment or from a form of remote tracking of information, it could only be conceived from the present moment. In this case, the time that would separate us from the Big Bang seems to be contained in the observer himself, by a principle of direct access exclusion. For this reason, the cosmic radiation used in tracking is called the background. When it comes to direct access, there would be a void of information in space, at least until the radiation carrying information about the Big Bang allowed the virtual inversion of the arrow of time next to us. The extent of this gap, according to science, would be 13.7 billion years. When we started tracking information remotely, we would be putting time's ground zero in our present, not at the Big Bang. Another curiosity is that when tracking a distant event through its light, as would be the case of the Big Bang, we would be seeing this event instantly, but with the appearance it had in the past. It is as if we traveled in time and watched, in real time, what would have happened in our past. This illusion also happens when you look at the night sky and see the stars shine. We usually don't realize it, but our memory seems to put us in two places at once. You are in the present, but you assume the time of the stars in the celestial vault, as if this time were passing here and now. Thanks to their time-displaced and phase-shifted images, the stars appear to you as they did in the past. Initially, Einstein had reason to think that the universe was static at its origin. With the advent of the redshifted radiation, showing the light of most galaxies tending towards the infrared, Einstein capitulated for good. He thought he would have made the biggest mistake of his life. However, inflationary theory predicts that all the matter we see expanding in the present would have been concentrated in a single point in space, smaller than the eye of a needle. Until the moment of the Big Bang, space and time did not exist. This point in space, of high temperature and extreme density, could be considered the center, the starting point of the expansionary movement. It is normally thought of as an isolated point, but the center could also be a two-dimensional plane. Someone who could be aware of his position in a flat place like this, in whichever direction he looked, would see all the stars shine at once, and the sky would be fully lit up. Recording such a place would be impossible for us, because, to interact with the universe, we depend on our memory, and, consequently, on the existence of time. In a flat space, time would not exist, because it could not be measured. Therefore, everything indicates that the Big Bang would have occurred only in the field of information, and together with the beginning of time, as evidenced by our dependence on the cosmic microwave background. Let's suppose that all galaxies were on the same two-dimensional plane, or on a single point in space, smaller than the eye of a needle. In this case, it would be necessary to unfold this place in 3 dimensions so that it could be perceived by our temporal memory. For time to be added to space, the latter would have to bend. Time would give depth to space, as can easily be seen in the figure of the future outcome of events. When time at its beginning, the Big Bang would have its own future light cone. For those who assess from the present moment, what is in the future does not exist, because it has not yet happened. Thus, time in the depth of space could only be conceived after the inversion of the arrow of time, with us in the present. Before that, time did not exist. As these concepts are often very abstract, we try to create images that are easy to understand. According to the theory, during the expansionary movement in the post-Big Bang, space would have assumed a behavior similar to that of a rubber band. It would have started to stretch continuously, pushing the galaxies away from each other with constant speed and acceleration. This model has many problems, which have made astronomers like hell. Stretching a rubber band creates tension between its ends, resulting in an increase in elastic potential energy. The resultant force points in the opposite direction to the stretch. Thus, if space were stretching in the post-Big Bang, galaxies would tend to collapse about the initial point in retrograde motion. An attempt was made to find a solution to the problem, imagining an energy that could overcome the force of gravity. It was called dark because, to this day, no one has been able to prove its existence. The Images of the Universe project defends the thesis that the universe was really static at its origin. However, this resting position of space, where there would be no forces acting, could not be apprehended by our memory. Even if absolute motion did not exist between galaxies, to see their stars shine in the night sky, time would have to promote relative and continuous motion between them. Otherwise, intelligent life could not have arisen in the universe. The model of a birthday balloon, in which we painted some dots on the rubber, representing the galaxies, illustrates that they would not abandon their positions while the balloon inflated. The movement would only be relative, as it would be the space between the galaxies that would be stretching in a veiled way. The only way to overcome the static universe controversy would be to consider space as someone sending a letter to a friend who lives in another country. With the advent of the internet, this situation no longer exists, but it serves to illustrate. The space in the sender's role would not deliver the letter in person. For that, it would use a messenger. The one chosen for the work, in the case of space, would be cosmic background radiation. When the friend received the message containing the information about the Big Bang, time would be standing between the two, and the sender space would be out of the process. If we considered that light would be acting in the form of a messenger, isolating space in the role of sender of messages, many questions about the universe could be answered satisfactorily. But, for that, we would need to understand how the messenger behaves, because its behavior would replace that of space. Light and space seem to form a continuous whole. In fact, science postulates that the continuum would be formed by time and space. However, as we have no way of evaluating the time that separates us from the stars, without the help of light, we would have a love triangle. Space will stretch, if the light says so. Although this effect is normally extended to space as well, it is the light that would stretch, shifting towards red. This would be the basis of inflationary theories. Light is the tool that allows us to assess the geometry of space. This is done indirectly, because, due to its limited speed, the evaluation is always done with delay. It is known that the mass of the Sun would be able to deflect the light of a distant star, passing in its proximity. In this case, the curvature around the Sun would be evaluated by light, and not by space itself. Thus, we cannot say, with certainty, whether the curvature was generated by the mass of the Sun, or by the independent action of space itself. Thanks to light, the chemical composition of the stars, their positions in space and their distance and time, are also evaluated. Even the existence of a black hole is assessed by the indirect effects of its gravity on light. In short, we are true slaves of electromagnetic radiation. The behavior of light, and all other forms of radiation, is illustrated in the mass spring assembly model. We constantly talk about this model in the Images of the Universe videos, due to the importance of the space messenger behavior. The harmonic movement that light performs has 3 stages, which are normally extended by science to space itself. Halliday and Resnick suggest that gravity would act along the lines of the aforementioned set. Imagine a block connected by a spring to a fixed end. This spring could be at rest, stretched or contracted. For physics, 2 bodies with mass, which were infinitely distant from each other, would be interconnected by the spring of space. This spring would be at rest at infinity. As the distance between the bodies decreased, the space spring would enter its contraction phase, and the potential energy, previously null at infinity, would gradually decrease. There could be no increase in potential energy between celestial bodies in spacetime, as it would only be expected during the spring stretching phase of space. This difficulty has not yet been overcome by the inflationary theory.